Yeah, thank you for coming. I'm a little bit surprised because normally in Germany not so many people are really interested in Brandenburg, but that's fine. Probably you might miss the second talker, which is Manuel Belo. We thought a little bit about talking about this project. We actually run together with Terrestris and Camp to Camp. But I'm in a good situation because he's talking later on his own talk, and now I just can drop all the stuff which is too technical for me and pass it over to Emmanuel. So please stay here if you're more interested in specific technical stuff. All right, yeah, what I'm going to talk about, first a little bit about us, which shows you where Terrestris is coming from, why we got this project a little bit. I have a strong focus on what do we mean with 3D underground data, and then I'm going to talk a little bit about 2D WebGIS and 3D data. Explain a little bit about the architecture and the setup, come over to 3D WebGIS and 3D data, go back a little bit to architecture and setup to show you what we've changed in order to do the 3D client. I have a short preview on the system here on the live system when the Wi-Fi doesn't crash. Yeah, and of course I'm going to talk a little bit about the problems we had, because when we got on this project we knew we were doing something which nobody did before in that case. Okay, a little bit about us first. Company of Terrestris. This is parts of our team. We're doing geoinformatics since more than 10 years now, especially in the web mapping context and especially in the open source context. We're doing some development in OpenLayers, GeoExt, and several other stuff. So we have a strong focus, especially on the client side of the web mapping stuff on that. Yeah, I'm talking a little bit about me. But the only really interesting sentence for you is I'm geographer. So I know really a lot, but nothing really deep. So please don't ask too deep on that. So going to my talk. This is a 3D geological map. I think everybody of you might have seen something like that before. So these funny colored polygons which just show which rocks are stretching out at what part. So this is a classical view. You can buy them everywhere. If you're lucky, you got something like that, which is a coordinate x, y, and which might be just the drilling somebody did into the underground and found out something like that. So we have a drilling, and we have a drilling profile, and this is quite interesting, just thinking a little bit about that, because you got an x and y coordinate, which represents the point, and you have a z coordinate for every horizon you have here, and even some attributes. So this is, on the same side, is kind of classical what we think of 3D geoinformation data. If you're even more lucky, you get something like that, which is a profile, and somebody drawed something like that, so you get an idea about the situation in the underground. I think it's clear this must be kind of model and nothing which is actually 100% the reality, something like that. And yeah, drawing that onto the state of Brandenburg, which actually paid for that project. It's in northeastern Germany. Probably you know Berlin, which is right in the center here. And what you see are the yellow crosses. These are the drillings they have, and you see the blue lines, which is a kind of seismological reflection investigation stuff. I'm not an expert on that, but we got data in these locations. And they even did something more. They interpolated kind of surfaces. So this is an example for the top of the Permian layers, and it looks something like that. Like a rough sea or something like that, which is just located on that. Okay, so thinking about that, coming to the point of 2D WebGIS, I can say, okay, I have some points, I have some lines, I have some polygons, what do we normally do? WebGIS. Just put it into 2D WebGIS stuff. And yeah, looks like that. And then you could do some clickable stuff on these funny images, funny drillings, show the images from the drilling profile, and then you're fine. So doing that, I think you get bored because this is not why you are here, and this is not why I am here. So we did some funny thing. We put the data in a new PostGIS 2.0 database, and that makes you happy, hopefully. And we can do some really interesting things with the data now. First thing I must talk a little bit about is how the data coming into the database. We have another part of the project, which are real geological scientists, and they do a 3D modeling of this data, which is really highly scientific and stuff like that. I said I'm geographer, I have no clue about that. So they put the data in a kind of proprietary model, which is called GST, and they can export the data as WKT. And from that point we get the data into PostGIS and do two main things with the data. And first of all, I'm just going to talk about this data one. We import the data into the database and form it to kind of point cloud. So we have tons of points in it, just X, Y, Z, exactly what I've shown with the drilling profile before. So it looks a little bit like that. We have the data like that in the database. And coming back to the idea with the geological drilling, again, this is a situation you normally have. You have a geological map, and you have a coordinate, and you drill it down there. But what we can do now is you can click anywhere, and we just create something like a virtual drilling on that point, because we have that point and put it into the database and look which layers are underneath that. And even we can do the same with these profiles. And I can show that here in the 2D web mapping client we have. So we have a tool here, and I just can click on Berlin and get the virtual profile, or do something like that with a profile line. Wait for a second, but I think the performance is not too bad, because you must think these are tons of points which are just requested, and we directly live generate something like that. So how we are doing that? It's, of course, it is virtual and it is kind of modeling, but it works because you see that lying X over there. This is my click point, and then we just go down. We know the strategy. We know there are a maximum of 12 surfaces, and they are in the same row always. So we have a kind of predefined maximum distance to every point we look, and then we just look for the nearest point, which is on our axis, when we just let fall down that point to the underground. And from that we just create a JSON string, send it to the client, and the rest is just programming stuff doing here. Okay, so let's have a look at the architecture, which is quite easy. We have a PostGreSQL PostGIS database. We have for the geo stuff GeoServer, and on the client side we have a classical architecture we use in our company, which consists of open layers, XJS4 and GeoExt2. So quite easy. Switching over to the same slide you've seen before, and to that block. Remember, we get the data, we import it to the database, and in the second part, which is called data 2, which is just kind of silly, we create real polyhedral surfaces within the database. So we have all the data together. It's something in between a grid and a tin, a polyhedral surface, something like that. It looks, after importing that, it might look a little bit like something like that. And why do we do that? It's as simple as it is. If you have only 2D and you have some polygon data, you just switch on the next layer. and you won't see the layer above. So that's classical problem. You all know about this base map issue in open layers and stuff like that. This is nearly the same. So what we really need is something like that, so that you really can get into the data in the underground. And yeah, that's what we actually did. And how did we do that? Remember the architecture from the 2D client, and this is the architecture from the 3D client. And you've seen there hasn't changed so much at that point. We just added a plugin to GeoServer, which is a V3DS plugin to GeoServer. The first point I can point to Emmanuel. He's talking a little bit more about that later. And we replaced the open layers part with a JavaScript library called X3dom, which is for representing X3D data, which is a format used in the internet. And again, I think it's part of your talk later, Emmanuel, so just keep in mind, keep sitting here if you're interested in that, and look later. And we have more or less the same architecture than for the 2D client. So what changed? We've thrown open layers out as a mapping library, replaced it with X3dom, and we added a user extension V3DS to GeoServer. And then we can go on and created something which connected the ExtJs framework with the X3dom. And yeah, I think here are some GeoExt developers, so don't be angry. It's just my idea to bring it closer to you what the idea behind that framework is, or that library is. I called it GeoExt3D, which is of course not part of the GeoExt program project at the moment. And we use a kind of API which was created on top of the X3dom library. And that enables us to use the same ExtJs elements, such as viewport or panels or something. So the two clients look very, very similar, and the usage is very, very similar at that point. So then we have some API methods, such as set scale set layer visibility to click on layers, so switch them off, set layer color, get state and set state, which is really interesting stuff, because it's not that easy to navigate in that client. And if you got a really good view you want to show in a presentation like that, so you can just save this JSON string and reload it later. And of course you have the possibility as an open layers to navigate with mouse keys and something like that. So just a quick look about on the architecture with a slightly different figure. On the left side we have our database. Here we have our GeoServer, which really serves the data to the client as V3DS. And which is very important at that point is the data is sent to the client. So it's not like in the 2D client where we mainly use WMS stuff. It's more like WFS. We really send the data to the client, and the rest is happening in the client. And especially the data later is rendered in the client. Okay, so we have a look on that as well. And yeah, you see it's nearly the same. It is the same framework. It looks a little bit different. And here you have your geological layers. You can switch them off and on again. And yeah, a proof that we really render the data in the client is when you just change a color, which is really done really fast within that client. You have some tools like I mentioned that method set scale, so you can do a little bit something like that. And you have different navigation methods which make it more or less easy, especially if you don't have a mouse, to navigate inside the stuff. And you see that now I was in front of you. You don't see that funny kind of overview map we have on the top right here, which shows your view onto the model at that point. So if I move around here with the mouse, it will always move and show where I am actually. Yeah, there's some more fancy things like the kind of hovering, going over the data, have some background information about the stuff, and yeah, as mentioned before, I always take the wrong one. I always can throw in pre-saved view. I also can put that into a text file, something like that, send it to a colleague, and he can just open the same situation as I did in that point. Okay. Problems. A lot of them. One problem, of course, is performance, because we send really huge tons of data to the client, and yeah, it was quite difficult to catch up with that. As you've seen in the preview on the system, we only have a short piece of data. We don't have the full state inside the client now, so that's a kind of compromise we did. So normally you do a kind of pre-selection in the 2D client, and then you pass it over to the 3D client and open it there. Of course, you could reduce the data density, but as far as I know, hopefully you come up with a new solution now, there is no real method within PostGIS where you really can filter out the data. And I think it's sort of a little bit dangerous, because I'm not a scientist who created that model, and just throwing out some points might really cause completely different data. Of course, you can enhance your hardware. That's what you always do. If something is slow, just put some megabyte of RAM in it or something like that. And of course, wait. Just wait. I think map server, the first map server map created took about 30 seconds. And now it's like this, just a few years later. And I'm sure that hardware and every element within that world will get better and better. The second problem was that V3DS is not officially supported by GeoServer. So we had to use a GeoServer UX. I think it was created by a kind of student or...
Someone in Portugal? Someone in Portugal?
Yeah, someone in Portugal, Emmanuel says, created that, and Cam2Cam took it over and made it usable for our project. And there was no RP on top of that X3dom library, so we had to create one as well. I think there were a lot of more problems, but in the end, I think it's a good showcase that you really can do something like that. And yeah, many thanks for listening. If you have questions, of course, you can ask, or if you look for me later, I'm the crazy guy with 2 badges, so you will find me. And yeah, okay, thank you.
Yes, are there any questions? Yes, what coordinates do you pass to the X3dom? German.
What?
German coordinate system.
German coordinate system, yeah.
Oh, like the,
So,
the country plane?
yeah.
Do you have to translate like the German coordinates into a specific center so that you don't have some problems with numerical precision?
No, there was nothing. I think if you've seen the system, you can't really talk about precision in that context. It's all modeled.
What I mean is that when you got some big numbers for coordinates, you can have some problems with 3D interactions.
No problems till now.
Is the application online for the general public?
It is online, and if you're smart, you note it the URL because it's just open. We are just in the moment we are in the process of finishing the stuff, and the code is already on GitHub, but it's not open yet. I guess I think it's one of your GitHub repositories, but of course we are going to.
Is your system capable of dealing with geological faults?
I'm geographer, said before. We have, I'm not quite sure about the 3D viewer, what really happens in that context. For the profiles and the drillings, yes, definitely.
I would have a short question. Did you for the W3DS request, you implemented the complete W3DS client for X3dom, or is it, how can I think about that?
No, we have implemented a complete W3DS request on the client side. We just used the request we needed for this data.
Okay, that's
So
the 3D scene graph, X3D scene graph just on the W3DS, or
So the client, based on the bounding box, sends a get scene request with the bounding box,
And then you have the data.
and then you receive the data.
you get an X3D scene graph and you just display it.
Yeah, exactly.
Any more questions? We still have time.
Did you try 3.js and in comparison to?
I didn't get it.
Did you try 3.js? That's a JavaScript 3D library for comparison with X3dom?
No, not really. I don't know if you did it when we wrote that offer. No.
Related to your performance problems, is it primarily the data transfer, or is it the rendering time?
Yeah.
Which?
It's the data transfer, definitely. It's really huge amounts of data, and the data is modeled for a desktop thing, anything like that.
No more questions? Okay, then thank you, Phil. Again.